Hi everyone, today I'm going to take you through what is integration, the skills that you need to be able to help your child with integration, and then into all the aspects of integration. So the process of integration, then calculating an indefinite integral, then calculating a definite integral, what the difference between the two of them are, then going into area between curves, areas above and below the x-axis, okay, and the differences that you'll see, and then finally into differential equations, and that should give you the tools that you'll need to support your child at home. So let's go into the process to begin with. So for integration is the opposite of differentiation, and differentiation is the topic that we covered before integration. Okay, now to actually integrate, we would add 1 onto the power, divide by the new power, and I'm going to add in a caveat in there and say that you would also add in the constant of integration for any indefinite integral. So an indefinite integral is one without limits. Okay, there it's there, written in fancy terms, and there, as you see at the end, is my constant of integration. Okay, so the constant of integration, as I've said, always has to be in for an indefinite integral, not for a definite integral, and we'll go into the process of why that happens later on. Okay, so let's take a look at it actually happening. Here's example 1. So as I said, we're going to add 1 onto the power and then divide by the new power. And then because it's an indefinite integral, no limits, okay, so no numbers on the integral sign, you would then add in the constant of integration. That can also be written as 1 over 3 x cubed plus c if you want to. Okay, so let's take a look with 1 as a fraction. So if you've got x to the power of negative 3 over 2, I want to add 1 onto the power. So what I'm going to do is I'm going to add 2 onto the top, because obviously 1 is 2 over 2. So I would get negative a half up there. Okay, then you're going to divide by the new power. Okay, now if you've got 4 divided by negative a half, then we'd never divide by a fraction. So you flip that fraction upside down and you multiply. Okay, so I would end up with negative 8 in there. So I would have minus 8 x to the power of a minus a half plus c. Okay, I should really have my plus c in there as well. Now, SQA will always say that if you leave a power as a negative, it's bad form. So we then have to manipulate this to be able to get a positive power. And the way we would do that is we take it underneath. Same, if it was a negative power on the denominator, I could bring that up onto the top line so that it would be a positive power. Okay, and if you want, you could look at the videos for laws of indices to help you with that. Okay, so let's take a look at some harder examples. So it states that in differentiation and integration, no function can be differentiated or integrated with if it's got brackets in it, if there are fractions, or if you've got any surds. Okay, so we have to then put it into a specific form, and we have to manipulate it so that we can put it in that form. So this one here. Now, I'm not going to integrate it to begin with, so that integral sign should still be there. I've then got, if it's squared, it's multiplied by itself. And it's dt at the end because it's written with respect to t, which just means it's got t's in it instead of x's. Okay, so I'm going to multiply this out using FOIL. So I would end up with t squared plus 6t plus 9. And now I don't have any fractions and any brackets in it at all, sorry. So I'm now ready to integrate it. So I take each term individually. So add 1 onto the power, divide by the new power. Add 1 onto the power, divide by the new power. And same. Just 9 would be 9t to the power of 0. Okay, that t isn't technically there just now. So if you add 1 onto the power, you would get 9t. Divide by 1. Okay, and then I'm going to tidy it up. I can't leave it like that because it's unsimplified. So there's nothing I can do with that t cubed over 3. Okay, but I can simplify this 6 over 2. 6 divided by 2 is 3. So I've got 3t squared plus 9t plus c at the end. Okay, now this second example looks quite tricky, but I'm going to write it slightly differently. Okay, so all we've done is to put that dx on the top line. Now this, I'm integrating a function with respect to x, which is why it's got dx at the end. As you can see, I've got a fraction and a surd on there. So first thing I'm going to do is I'm going to change my surd into an index. okay, because that's the square root. So the square root of x to the power of 1. So that will become your fractional power. And then, as we said before, you can bring that up into the top line and make it negative. Okay, now it's ready to integrate. So if I want to add 1 onto the power, I would end up with x to the power of a half and divide by the new power. Okay, so I've got 1 divided by a negative a half, which is going to give me negative 2. As I said before, you flip it upside down and multiply by the new power. And I've got plus c in there. Now I don't have to do anything to that because I've got a positive power and it is simplified. Right, so limits of integration. Now, what do we use integration for? Now, we use integration with limits to find an exact area that's bound between two curves or bound between a curve and the x-axis. Okay, now you've got an upper limit and a lower limit. So as you can see, this integral would have an upper limit of b and a lower limit of a. So the integral itself would be written like that. Then with the function, and dx at the end of it's written in x. Okay, so calculating definite integrals. I've got 5x squared, so the first thing I'm going to do is I'm going to integrate, right, so I'm putting in square brackets because I know I've integrated and I don't want to see that integral sign. So I'll get x cubed, add 1 to the power and divide by the new power. Okay, and then my limits go in here. There's my upper limit, there's my lower limit. Okay, and I substitute both of these in. So I've got 5 over 3, substitute in your 3, and then substitute in your 1. Okay, now this can come up in a non-calculator and calculator paper. So I would end up with, apologies, let's get rid of that. Okay, so this one will give me 45. I've chucked it into my calculator, and this one is minus 5 over 3. Okay, so what I would get is I would have 130 over 3, and that'll be in units squared since it's area. Okay, so the second one looks a bit trickier. Again, I'm going to take each term separately. So add 1 to the power, divide by the new power, add 1 to the power, and divide by the new power. 3 over 3 is just 1. Okay, and there's my limits, 0 and 2. So now I'm going to substitute in the 2. My upper limit first. Okay, and then substitute, take it away, and substitute in your lower limit. Now I love substituting in 0 because most of the time it's just going to 0, which is what this is. Okay, so I would end up with 12 in there, that's minus 0, so I would have 12 units squared. Okay, so that's calculating a definite integral, and as I've said before, you don't have the constant of integration with a definite integral because they're exact. Okay, area above and below the x-axis. So areas above the x-axis will give you a positive integral. Areas below the x-axis will give you a negative integral. So what I'm saying there is I'm saying that the answer that you get out if it's above, the areas above the x-axis will be positive. If it's below the x-axis, the answer that you get out, or the number you get out, will be negative. Obviously, you can't get a negative power, so we just use the positive of that negative. Okay, it might look like this. There's your positive area, there's your negative area. Okay, and again, as I said, it can't be negative, so we use the positive value. Right, now, point to note, 2 separate areas, so you must calculate 2 separate integrals. There it's there, sorry. Okay, so you would have 2 integration signs here. You would find the area of both of them, and then you would add them together at the end. Right, so let's take a look at it. So what I'm going to do is I'm going to integrate. I'm going between 1 and 4 to begin with, and I've got x squared minus 4x dx. That's my first area. My second area is between 4 and 5, and you can tell that the function is the same, so I only really have to integrate it once. Okay, so let's integrate it. X cubed over 3 plus 4 x squared over 2. Okay, so I'm going to simplify that at this stage and just give you the 2. And that'll be between 1 and 4. So this one is obviously going to be the same. Function x cubed over 3 plus 2x squared, and that's going to be between 4 and 5. Okay, so I'm going to take this one across here. I'm going to sub in my 4. So I would end up with 4 cubed over 3 plus 2 times 4 squared minus 1 cubed over 3 minus 2 times 1 squared. Okay, then tuck it straight into your calculator. Minus 32 over 3, and that'll be minus 5 over 3, and that'll give you negative 9 units squared, which obviously, since the area is below the x-axis, the area is actually 9 units squared, and we'll use the positive. Okay, so we're going to do exactly the same for this one. We're going to substitute in our 5. So we get 5 cubed over 3 minus 2 times 5 squared. Okay, and I would substitute in my 4, but I've already done it and I've got an answer of minus 32 over 3. Okay, so once I evaluate the first bracket and I chuck it into my calculator, I get minus 25 over 3. I want to add that 32, 2 negatives will give me a positive in the middle here, over 3, and I get 7 over 3 units squared. So the total area will give me 9 plus that 7 over 3 to give me 34 over 3 units squared. Okay, right, so let's move on. That was area bound by a curve. Okay, area between two curves, this is slightly different, okay. Now, if you've got two of them sketched on the same diagram, it automatically creates that area in between the two of them, and it could look like this. Okay, so to find the section underneath, we calculate the area underneath all of it, okay, and then we subtract what's on the lower one from it. Okay, and the integral will look like that. Right, in most cases you will need to find the limits of it, and we do that through simultaneous equation. I'll take you through a question just like it in a second. Okay. Right, so the area bound between two curves between x is equal to a and x is equal to b is calculated by the upper minus the lower. Okay, here are the steps for it. Okay, if there's no limits, set both functions equal to each other and solve simultaneously. That's called simultaneous equations by substitution. Right, you then write out the integral and identify which is the upper function and which is the lower function. Okay, as we said before. And then simplify the expression for the upper minus lower. It'll make the algebra so much easier. Then integrate it, substitute in your limits, your upper limit, substitute in your lower limit, take the two of them away and you'll find the area. Okay, so again, let's have a look. So we've got two curves, this one here being the upper curve, okay, with this one here being the lower curve. So we would have 6 minus 3x squared minus bracket minus 3 minus 2x squared. And as you can see, I don't know what my limit is. I don't know where these two meet. Okay, so my limits would be there, but I don't know what they are, so I'm going to have to find them. Right, so I needed a full page for this. It's going to be quite something. So we've got y is equal to 6 minus 3x squared, and we've got y is equal to minus 3 minus 2x squared. Okay, so the first thing we're going to do is we're going to set them equal to each other and solve it to find the limits. So sorry, typo. Okay, bring it all over and set it equal to 0. So I would end up with minus 9, balance the equation, plus x squared. If I rewrite that, I'll get x squared. It might be more notable. I've got a difference of 2 squares, so I now factorise it, x plus 3, x minus 3. So my limits are x is equal to minus 3 and x is equal to 3. So I've got my upper and lower limit. Okay, now unfortunately I'm going to need the space, so I need to rub this out. Okay, now my integral between minus 3 and 3, that's what we've just found, is the upper integral, which, as you can see from the diagram, let's go back, was 6 minus 3x squared, and then you will take away the second one from it. So let's have a look at what that looks like. You've got 6 minus 3x minus 3 minus 2x squared. Now, let me point out this. Okay, because you're taking it away, I would always put the second function in brackets because you have to multiply through by this negative, okay, which will change the signs of the other ones, and a lot of candidates find that difficult, and that's where they'll make mistakes. Okay, so let's multiply it out. So I would have 6 minus 3x plus 3 plus 2x squared. Okay, so let's keep going. Let's tidy it up, and I get 9 minus x squared in there between 3 and minus 3. Okay, so now I'm ready to integrate it. So I'm going to integrate it. 9x minus, add 1 to the power, divide by the new power. Okay, substitute in your limits. So I would have 9 upper limit first. Lower limit second. Okay, so for the first one, chuck it into your calculator, you've got 18 minus second one minus 18. Okay, add the two together, two negatives make a positive. So your total area is 36 squared units. Okay, so we've got 1 point apart of integration left, which is your differential equation. Okay, now your differential equation, although it sounds as if it should be part of differentiation, it is how to reverse differentiation. And as we said at the beginning, integration is the opposite, or the reverse, if you like, of differentiation. And this is why we use the constant of integration, because we can't always say that there's not a number at the end of differentiation. So that's why the constant of integration is there, and this is the process to find it. Okay, now these questions are very easy to identify, because you'll end up with a derivative at the beginning and it will say express y in terms of x. Okay, so let's have a look at it. We're going to have, I want to integrate it to get back, so integrate x squared minus 5 dx. Okay, so add 1 to the power, divide by the new power. Don't know why I put my squared in there, that's not true. Add 1 to the power, divide by the new power. Don't forget your constant, because it's an indefinite integral, and we're back to where we started with the original function y, and that's what it's saying here. Okay, so now they've given me an x coordinate and they've given me a y coordinate. Okay, so the y coordinate comes in here and the x coordinate gets substituted in for each x. Okay, so I would have 9 minus 15 plus c minus 4. So minus 4 is equal to negative 6 plus c. Okay, so 2 is equal to c. I've first found my constant of integration, and it is good form to then write out the original equation in its entirety. And that's you done. Okay, so I'll give you another one because it can come up in different forms. As you can see, this one's slightly different. Okay, it still says find f of x. Find f of x in terms of x, okay, but this time they're giving you f dashed of x, which again is the same thing, but they've given you f of 1 is equal to 4, and that's your coordinate in there. That's them telling you that x is equal to 1 and y is equal to 4. Okay, so the same thing's going to happen. I'm going to integrate, and I want to add 1 to the power and divide by the new power. Okay, this one should be in the form of minus 2. Remember, you don't want any fractions in there. Okay, and 2/3 is just a number anyway. So add 1 onto the power and divide by the new power. Okay, so I've got f of x is equal to, I'm just going to tidy it up a bit slightly because I don't like that second term. That's going to give me minus 1 over x plus 2/3 x plus c. Okay, I'm then going to take my x is equal to 1 and my y is equal to 4, and I'm going to substitute these in here. I've got 4 is equal to, I'm just going to get rid of some of the bit at the side. Sorry. Hang on. There we go. Right, so I've got 4 is equal to 1/3 minus 1 plus 2/3 plus c. So I get c is equal to 4. And as I said, it's always good form to write it out at the end. So I've got f of x is equal to x cubed over 3 minus 1 over x plus 2/3 x plus 4. And that would be my final answer. Okay, so what we've done is we've taken you through each aspect of integration, all the skills that you need to answer these questions, but ultimately to integrate you would add 1 to the power divided by the new power. We've then taken you into the fact that it can't have any fractions, brackets or surds when you go to integrate it, so you need to manipulate that algebraic expression. Then the uses of integration, okay, so your definite integral will not have a constant of integration because it's an exact value and you're evaluating the area under a curve. Okay, so we then went into areas above and below the x-axis, and then area bound by two curves, and then finished off with differential equations. I hope this helped.